This is the third comprehensive session of distribution equipment training with me, Ali Ezzat Kasti. In this particular and very important session, we're going to get much more familiar with the essential junction box, learn precisely how to properly connect the load cell to it, and thoroughly go over its various settings together. Please stay with me for this informative session. Well, in the previous lesson, we got acquainted with a simple distribution system. We said that a simple distribution system consists of a load cell and a weight display unit. When we apply a significant and measurable force to the load cell, we can clearly and precisely see the exact weight placed upon the load cell on the connected display unit. In some specific cases, instead of just utilizing one single load cell, we might strategically employ several load cells. For example, we might effectively use 2 or even more individual load cells in a particular setup. Like this system that you are seeing right now, here 2 separate load cells have been effectively utilized. So in those specific cases where we have more than one individual load cell, so like in this example you see here, where 2 load cells are used, for instance, let's consider a scenario where if the precise location where these load cells are meticulously installed is completely and perfectly level, and the substantial tank placed upon these load cells is also perfectly and absolutely level. And furthermore, the material whose exact weight we are endeavoring to accurately measure, like in this particular example, it is pure water, if it is distributed absolutely evenly over the 2 individual load cells, meaning that the entire force which the water applies is exerted equally and symmetrically on both of the load cells. We can now effectively connect the 2 individual load cells in parallel, then hook them up to a dedicated weight display unit and subsequently calibrate it. But in cases where the place where these load cells are installed is not completely level, for example, if it's a sloped surface, more force might be applied to one of the load cells, for instance. Or, for example, less force might be applied to one of the load cells. Or the material whose weight we want to measure might not be distributed evenly across the load cells. For instance, one side might apply more force while the other side applies less. In this particular situation, we frequently use a specialized device called a junction box, which is also commonly known and widely recognized as a summing box. Throughout the subsequent sections, we will thoroughly get familiar with its various operational settings and the diverse types available. Now, in this particular example, suppose our surface isn't completely flat, and here we've actually used 2 distinct load cells. Since our surface isn't entirely flat, more force is applied to one side and less to the other. That is precisely why we use a summing box, or alternatively, a junction box. In this particular and precise way, we meticulously connect each and every one of the individual load cells directly to one of the designated inputs of the summing box, and then from the primary output of the summing box, we carefully take a connecting wire and securely connect it to our essential weight indicator. Subsequently, we proceed to accurately calibrate the indicator, and by diligently utilizing the various potentiometers located precisely inside the junction box, we are able to effectively correct any potential imbalance that might be caused by the presence of a sloped or uneven surface. We will thoroughly explain further in more comprehensive detail exactly how to properly adjust those crucial potentiometers that are situated inside the summing box. Or for example, in specific cases where we have a large tank with 4 sturdy legs and we want to accurately measure the total weight of this entire tank. Well, in this particular case, we typically say that we strategically place a sensitive load cell directly under each of the tank's supporting legs. Like in this particular image, as you can clearly see, we have carefully used a load cell positioned under each of the tank's supporting legs. So now the important question is, how exactly should we connect these 4 individual load cells to the display unit? Here, the issue of being level or unlevel and such things is no longer relevant at all. When we have more than 2 individual load cells, we definitely need to utilize a specialized junction box. So in this particular scenario, we can clearly state that each and every one of our load cells is meticulously connected to this central junction box, specifically the first primary load cell, then the second crucial load cell, followed by the third essential load cell, and finally the fourth and last load cell. Subsequently, from the output terminal of this summing junction box. We then proceed to connect it directly to our digital display unit. If we accurately calibrate this display unit, we will then be able to precisely observe and read the exact weight that is currently being applied to these 4 interconnected load cells. Now here, as you can see, we practically have 4 load cells here. We have successfully connected these 4 individual load cells to our summing box. Here's another practical example to consider. Imagine a robust industrial tank, specifically designed with 4 sturdy legs for stable support. Underneath each and every one of these 4 supporting legs, individual load cells are precisely placed. These highly sensitive load cells are then meticulously connected in a specific configuration to a central summing box, which is also commonly referred to as a junction box, where their signals are combined and processed. Now moving on, we will become thoroughly familiar with the various and distinct types of high-quality junction boxes that are produced by the reputable CONTROLSEWHA brand. I should also mention that CONTROLSEWHA produces summing boxes in 4-channel, 6-channel, and 8-channel types, offering versatile options. This means that in essence, if we use a robust 4-channel summing box, we can meticulously connect 4 individual load cells directly to it and then seamlessly connect its primary output to a dedicated display unit. Now, considering a scenario where our tank is, for example, significantly larger in its overall capacity, or if we happen to possess a weighing scale system that specifically employs, say, 6 distinct load cells, again, in this case, we can use a 6-channel junction box. Or if we happen to have even more load cells that need to be connected, we can certainly utilize an 8-channel junction box for that purpose. Well, specifically within the CONTROLSEWHA brand of products, our reliable junction boxes all consistently start with the distinct SB prefix at the very beginning of their unique product codes. Then we say that they are produced in 3 different sizes, S, N, and L, which specifically stand for small, medium, and large sizes. The precise dimensions are clearly specified here for your convenience in the comprehensive catalog, so you can thoroughly check them out at your leisure. The particular models that prominently use the letter P here in their designation have a durable plastic body, meaning they are indeed made from high-quality ABS plastic, which is a very common and robust type of dense plastic material. As we previously mentioned, these excellent models come in a variety of configurations. 4-channel, 6-channel, and 8-channel models are all readily available. In addition to the plastic models, CONTROLSEWHA company has also produced a series of junction boxes with stainless steel bodies, meaning they are made of stainless steel, which we indicate with the letter L. And currently, only the medium models are actually available, which are produced in 4-way and 6-way types. Also, for environments where you need to use explosion-proof equipment, these are suitable as well. The CONTROLSEWHA company has successfully produced a junction box that is indeed explosion-proof, meaning it is officially explosion-proof certified, and its specific model is SBMA04, which is a 4-way type and also comes complete with certification. Well, if we were to carefully open up a standard 6-way junction box, inside this particular junction box we would clearly see a circuit board that looks precisely like this one. Now, we genuinely want to get much more familiar with this intricate board that is located inside the junction box, and specifically these various potentiometers that you can distinctly see here, and subsequently find out precisely what the essential function of these individual potentiometers truly is, and exactly how we can effectively adjust a junction box to achieve optimal performance. So this is actually a comprehensive 6-way junction box board, which inherently possesses several distinct and important sections. For example, this particular part is directly related to our first load cell, and based on the clear labels on the board, we can connect our essential load cell to these specific terminals. This section is for positive excitation, negative excitation, positive signal, negative signal, and finally we can connect the shield to this part. And here a potentiometer has been placed, which is related to our first load cell. This section is for our second load cell. Again, in precisely the same manner, according to the clearly visible labels on the board, we can proceed to connect our essential load cell directly to this designated terminal point. This particular measurement is also specifically for our third load cell, the fourth individual load cell, the fifth distinct load cell, and finally our sixth and last load cell. Each and every one of these crucial load cells that we meticulously connect here possesses its own corresponding and dedicated potentiometer, and we will thoroughly explain later on precisely how we can accurately adjust these important potentiometers. Well, this particular part is also directly related to the essential output of our main junction box, which we can then conveniently connect to the primary weight display. Now let's carefully observe and see precisely how these important load cells are effectively connected to the main junction box. Here, let's assume for this example that we have 4 individual load cells. We want to connect these 4 load cells to our junction box. As we previously explained in detail, each individual load cell is equipped with 5 distinct wires. 2 of these wires are specifically designated for the positive and negative excitation, providing the necessary electrical input for its operation. 2 others are for positive and negative signal, and there's also 1 shield wire. And as we have mentioned, we carefully connect each of these individual load cells to our summing box precisely according to the specific labels that are clearly indicated on the junction box board. So based on the clearly visible and distinct labels meticulously placed on the board, as you can readily observe and understand, we proceed to carefully and precisely connect each and every one of the individual load cells, ensuring a secure and reliable attachment directly into our specialized and robust junction box, which serves as a central point for consolidating these crucial connections. And after we have successfully connected all of the load cells, we can then utilize a dedicated display unit and subsequently connect our display unit to the junction box as well, ensuring a complete and functional system. Now, considering that the labels that are on the board, we can also connect the display to the junction box. After we've connected the load cells and our display to the junction box, we need to calibrate the display. Alright, here we have utilized a small yet highly functional weighbridge. Our particular weighbridge is thoughtfully equipped with 4 robust and precise load cells. We meticulously aim to connect these 4 essential load cells to our dedicated junction box. And subsequently we will finally connect the crucial output signal of this junction box to a clear and easily readable display unit. Ultimately, our primary objective is to accurately observe the precise weight of any substantial load that is carefully placed upon this weighbridge and have it prominently displayed on the screen for immediate viewing. So first, we carefully connect each of these individual load cells to the designated junction box. Based on the clear color coding of the load cell wires and the prominent labels on the junction box, we meticulously connect each of these load cells individually to our primary junction box, and finally we then connect our display unit to the output of the junction box. We carefully calibrate the display unit according to the maximum capacity of this load cell, and subsequently, after completing the calibration process for the display, we proceed to utilize a standard weight. For instance, we might employ a 20 kilogram weight. We carefully place the standard reference weight onto this specific part of the precision scale and then meticulously observe the precise weight value that is clearly displayed on the digital screen. If the weight that is shown on the display is exactly 20 grams, then the calibration is considered accurate, just like what you're seeing here right now. Well, this means that everything is correct and there is no need for you to do anything with this potentiometer here at all. In other words, it is working properly. But sometimes you place this 20 kilogram weight on this part of your scale, but instead of the display, it shows a value other than 20. Well, in such specific and particular cases, we typically use a specialized screwdriver to carefully adjust this particular potentiometer, meticulously turning it with precision until the digital display clearly shows the precise number 20. And after the display has definitively shown the exact number 20, our potentiometer is then considered to be perfectly and accurately set. This particular junction box is an analog circuit, and we absolutely have to adjust each and every one of these potentiometers manually, that is to say in a completely analog way. Now, after we've successfully connected our very first load cell, carefully calibrated the display unit, and precisely placed the 20 kilogram weight onto it. And this is precisely what we call it, so to speak, in this particular context. We've set aside this back calculation. Now we move on to the second individual load cell. We will carefully disconnect the wire of the first previously connected load cell from its designated junction box, and this time we will then securely connect our second new load cell directly to the junction box. Additionally, we will also connect our digital weight display unit to the very same junction box, ensuring all components are properly integrated for accurate readings. And we calibrate the display according to the capacity of the load cell. After carefully calibrating the display, this time we will precisely place the 20 kilogram weight on this specific part of our sensitive scale. And again, if it doesn't accurately show us the precise number 20, meaning there's some sort of error or discrepancy, by carefully adjusting this potentiometer, which is a variable resistor, we can effectively correct the displayed weight value. We can then continue turning it, making small precise adjustments until it clearly and accurately shows us the desired number 20. In precisely the same manner, we can then proceed to safely disconnect the second load cell and subsequently connect the third load cell to the junction box, ensuring a secure and proper connection. And we calibrate our display according to the capacity of the load cell, and this time we place the 20 kilogram weight on this part. And if it is absolutely necessary to precisely adjust this particular potentiometer, we can certainly adjust it. And finally, we meticulously do precisely the same for the fourth and final load cell. That is to say, we carefully connect the fourth individual load cell, then connect the display unit, subsequently calibrate the display unit with great care, and this time we very carefully place the 20 kilogram calibration weight directly on this specific part of our weighing scale, which precisely corresponds to this particular load cell. If it is indeed needed, we can then adjust this specific potentiometer as well. This entire process is quite commonly referred to as the crucial corner adjustment of the weighing scale, or alternatively, adjusting the various potentiometers of the junction box. Well, in this illustrative image, you can clearly see a robust scale platform. Inside this robust scale platform, 4 precise load cells and a single essential junction box are meticulously utilized. We can effectively connect these individual load cells to the central junction box and then subsequently connect its output signal directly to the digital display unit. If we carefully calibrate the display and, for instance, precisely place a substantial 100 kilogram weight upon our sturdy scale platform, we will then observe the exact numerical value of 100 clearly displayed on the screen. Thank you very much for your kind attention and valuable time.